Greetings to you all. In the previous video, we looked at configuration of the DHCP server, which is a very important protocol in allocating IP addresses dynamically to our network host as they are accessing the network. Remember, in the DHCP server option, we configured one default gateway. So what happens if this gateway cannot be accessed? I think you can guess it, we cannot access other parts of the network. So this is where the virtual router redundancy protocol comes in to implement gateway redundancy. So this video is going to have two parts. Part one, we're going to look at the brief description and the mechanism of how the virtual router gateway redundancy protocol works. And we're going to do some reconfiguration of our network devices if you are still following along with this particular setup we are dealing with, this scenario. Or then part two, we're going to do the configuration of the virtual router redundancy protocol. So we shall start with a brief description in this part one video. So a virtual router redundancy protocol uses two devices. One acts as the master and the other acts as the backup. So these two are supposed to have IP addresses in the same subnet. For example, considering our service desk network, we shall assign an IP address of 192.168.100.2 to the master. Then we shall assign an IP address of 192.168.100.3 to the backup. Then our gateway is going to be the virtual IP address. As you can see, the virtual router redundancy protocol uses 3 IP addresses, but all of them must be in the same subnet. So one IP address for the master, another IP address for the backup. Then the virtual IP is our default gateway that we assign to our particular network host in our in this subnet where we are implementing redundancy too. So how does it work? For example, right now, if desk one sends an IP address to access any other part of the network, it will target the virtual IP address as its default gateway. Then remember, core switch one is acting as our master. So this virtual IP address will forward that packet to the master. So if the master is offline, maybe it blow up, the backup will take up the master role. So in this case, the desk one computer will send the packet to the virtual switch, and the virtual switch will forward the packet to the backup switch, which is core switch 2, because core switch 1 is offline. So briefly, that's what I can give you. That's a simple description I can give you. So let us go ahead and reconfigure our network switches so that we are in the next video able to implement the gateway, the virtual router redundancy protocol. For those who are continuing, yeah, we can continue along. Then for those who are just looking at implementing the protocol, you can go ahead and use the part 2 of this. So for those who are continuing, so you're going to first go to core switch 1, and then you shall go into system view. System view, remember we are having one static IP binding. So first view our previous configuration. Remember, in our service pool, as you can see, we are going to use this 192.168.100.2 for our core switch 1 IP address. So remember, this IP address is bind to one of our network hosts. So we are going to need to remove that. We shall do IP pool service. Then we shall do undo static binding. Let's do and static bind. So now it has been removed. So we can cd back. So we can quit, sorry. So display configuration. So as you can see here, it has been removed. So now we don't have any static bind IP address. So we are going to go to, as you can see, the interface VLAN, the layer 3 interface VLAN is also having, this is going to be our virtual IP address for the VRRP group you're going to be using. So remember, we're going to have core switch 1 and core switch 2 in this particular VRRP group. So we need to assign this particular IP address to this VLAN interface of this core switch 1. So we shall go into interface VLAN if 10. Then we are going to do IP address. Then we are going to assign a new IP address of two IP address 192.168.100.2.2. Then our subnet is 27. Okay, hope that is done. Display current configuration. So you can see we don't have that there. Then our interface VLAN 10. Yeah, it's having that particular IP address of 2. So we are done with this. We can go ahead and save our configuration. Quit, save. Okay, we are done with core switch 1. So we are going to go to core switch 2, which is going to be our backup. So let us do display current configuration. Let's see. As you can see, we don't have a layer 3 interface for VLAN 10, so we're going to create that interface VLAN if, then we're going to create 10. And remember, we are assigning this particular interface an IP address of 3.192, but in the same subnet as that one, of course, which one is going to be 3, then the mask is 27. We are good to go. Remember, we are good. This protocol is going to implement also DHCP server redundancy. For those who are continuing, I'll hit about it in part 2. Those who will be starting with part 2 only. So this one is going to also to implement DHCP server redundancy. Remember, core switch 1 is acting as a DHCP server. So in order, when core switch 1 fails, the host should be able to get IP addresses from core switch 2. So we shall look at that briefly also as we continue the configuration. So we can check our current configuration. We can see to verify. As you can see, we have 192.168.100. Yeah, we're good to go. Then we have to change one interface, which is the uplink. For the access switch 1 to this, which is interface gig 04. Here on my network, I don't know which interface it is. So that is interface. If you look at interface gig 04, you can see there is no currently any configuration. We need to change it to trunk. Interface gig 04 port link type. We're going to change it to trunk. Then port trunk, allow pass VLAN. We're going to say 10, 20, 30, 40, and 50. So we're good to go. Display current configuration to verify that that is set. Okay, gig 04. Gig 04 is a trunk and it's allowing our VLANs to pass through. That's good to go. So we are going to also save. We're going to save our configuration here. And lastly, we are going to go to our access switch. It's uplink, which is gig 002. Interface gig 002. So we are going to change also its port link type to trunk. We are going to port and trunk, allow pass VLAN 10, 20, 30, 40, 50. Quit display current configuration to verify that. So this is trunk, and we also verify that from here gig 02, yes. So you can also go ahead and save this, and we're good to go with that configuration. our lab environment is ready to implement the virtual router redundancy protocol. So we can verify that we can ping the other core switch by 192.168.100.2 to verify our configuration. Yes, traffic is reaching. So that's just to add another verification. So we can save that. Hopefully we saved here, yes, and also we have saved here. So with that, we are ready to configure our virtual router redundancy protocol. See you in the next video. If you haven't subscribed, consider subscribing to support the channel. So we shall meet in the next video. Thank you.